Okay, so today we're going to talk about exponents. So this is a new unit called the exponential functions. All right, so the review is something that we did at the beginning of the year. So it's your laws of exponents. So just a quick review. Hopefully you remember how to do them. So put me on pause, give them a try, and come back and let's see what you have. All right, so we have here, number one, it says x to the fourth times x to the second. So remember, when you're multiplying and you have the same base, you add the exponent. So this would be x to the sixth power. X to the second times x to the fourth is x to the sixth. When you have a power to a power, you multiply the powers. So x to the second to the fourth would be x to the eighth power. This is, you have a power of a quotient. So we're multiplying. I have x to the second times x to the third, y to the third, raised to the third power. So each one on the inside gets that third power. So it's x to the second to the third and y to the third, which is going to be x to the sixth, y to the ninth. Because remember, power to a power, you multiply the powers. All right, when you divide same bases, you subtract the exponent. So x to the fourth divided by x to the third would be x to the first, which is just x. All right, this next one would be power of the quotient because I'm dividing. So each one gets the power. So it's x to the second to the fifth over y to the fifth. So power to a power, you multiply the power. So it's x to the 10th over y to the 25th. And you can't subtract them because they're not the same base. All right, so let's take a look at 6. I have the same bases here, so I can divide them and subtract the exponents. So x to the negative 3 divided by x to the second, so it's negative 3 minus 2 would be x to the negative 5. And then I have y to the 6th divided by y to the negative 4th, so that's 6 minus negative 4 is y to the 10th. And hopefully you remember, when you have a negative exponent, in order to make an exponent positive, it goes into the denominator. So this is equivalent to y to the 10th over x to the 5th power. Remember, you could take your base and the exponent and shoot it into the denominator, and it becomes a positive exponent. X to the 0, 5 to the 0 power is equal to 1. Anything to the 0 power is equal to 1. Let's just take a look at the next one here. It says, true or false? Is 1.085 raised to the 4t power equivalent to 1.38585870701 to the t power? So I have a power here. So this is really hold on, I'm just going to move everything up here. So I have this 4t power. So this is really 1.085 raised to the 4 times t power. So remember this rule over here, when you have this power to power, that comes from multiplying, and you get x to the 8th, that comes from multiplying, right? It's x to the 2 times 4 power, which means one of them has to go onto the inside. So I'm going to take the 4 now and put it on the inside. So it's 1.085 to the 4th power to the t power. So far, all of these are the same here, right here. So now I want to know, is this? Well, let's plug this 1.085 to the 4th power into the calculator. So type that in and let's see what you get. You get 1.385858701 still raised to the t power. So is it equal? That is true. All right, so that's actually what we're going to be working on today, is different ways that you can write exponents. All right, so let's take a look at number 1. Sorry, my copy's very blurry today. So it says rewrite. The first one says rewrite as a power of t. So that's kind of like what we just did. I have 3 to the 4t power. So that's really 3 raised to the 4 times t power. So I can now group this together because remember, I have this rule, 3 to the a times b power comes from 3 to the a to the b power. So I could write this as 3 to the 4th to the t. Now plug 3 to the 4th in your calculator, and 3 to the 4th is 81. So it's 81 to the t power. So all of these are equivalent, all of these here are equivalent to each other. All right, let's take a look at 2. 1.085 raised to the 4t power. So that's the one we just did. So that's 1.085 raised to the 4 times t power. So now I'm going to put the 4 on the inside. So I have 1.085 raised to the 4th power raised to the t power. And then plug this into the calculator and you get 1.3, sorry. 3.85858701 raised to the t power. Okay, so let's take a look at the right side here. So the next one says write as a power of 12t. So when I'm done, I have to have a 12t power there. But it has to be the same number. So this is what I want. I want to take 3.25 and I want to raise that to the 12t power. So it still has to be this answer when I'm done. But I need to have a 12t down here someplace. But when it's simplified, it still has to be 3.25 to the t power. And remember, this is multiplying here. So what could I put here? Sorry, what could I put as an exponent here? And remember, when I have an exponent to an exponent, I multiply the exponent. So that when I multiply this something times my 12t, I have to get t as an answer. Because that's what I have here, 3.25 to the t power. So what number could I put in this circle? So 12 times 1/12. 12 times 1/12 is equal to 1. So I can raise this here. This exponent here is 1/12. So 3.025 to the 1/12 power to the 12t is equivalent to this. Because this actually here, this becomes just t. All right, so let's take a look at number 2. Same thing. I want to take 1.025 and I want to have it raised to the 12t power. So what do I need on the inside so that when I multiply it times 12t, I get just t? And that would be 1/12. So my answer is 1.025 to the 1/12 power to the 12t power. Okay, so that's it, and we'll practice it in class tomorrow. Have a good night.